Hello everyone, this is Jayasri Bhangre working as an assistant professor at Maratha Vidya Prasarak Samaj, Nasik. Welcome to the seventh part of 8051 Microcontroller, that is interrupt registers. So these are the objectives of today's video, that is we are going to introduce what is interrupt. We are going to study interrupt enable register, interrupt priority register. So what is an interrupt? Interrupt is nothing but a way to serve the several devices connected to a single microcontroller. In interrupts, whenever any device needs its service, the device notifies the microcontroller by sending it an interrupt signal. And upon receiving this interrupt signal, the microcontroller interrupts whatever it is doing and serves the device. So this is the definition for interrupt. An interrupt is an external or internal event that interrupts the microcontroller to inform it that a device needs its service. And the program which is associated with the interrupt, or that is the small program written for that interrupt, is called interrupt service routine, that is ISR, or interrupt handler. Vector interrupts. All the available interrupts in 8051 are vectored interrupts. Vectored interrupts are nothing but the interrupts that has a specific address. So devices that use vectored interrupts are assigned an interrupt vector. This is a number that identifies a particular interrupt handler, and the ISR address of this interrupt is fixed and known to CPU. When the device is interrupts, the CPU branches to the particular ISR. All the 8051 interrupts are vectored interrupts. So there are 6 interrupts in 8051, that is reset, power up reset. There are 2 interrupts set aside for timer 0 and timer 1. They are called as internal interrupts or software interrupts. Then there are 2 interrupts are set aside for the external interrupts, that is int 0 and int 1. They are called as a hardware interrupt. And serial communication has a single interrupt that belongs to both receive and transmit the data. So let's see the priority assigned to this interrupts. Int 0 that has a highest priority, then TF0 that is nothing but the flag for timer 0. It has the lowest priority than int 0. Int 1 has the lowest priority than int 0 and TF0. TF1 that is flag for timer 1 has the lowest priority than int 0, TF0 and int 1. And RI and TI that is serial port interrupt has the lowest priority. So each interrupt has a specific place in a code memory where program execution or ISR begins. So these are nothing but the vector addresses for the interrupts. So int 0 has vector address that is 0003H. TF0 that is the flag for timer 0 has a vector address 000BH. For int 1 vector address is 0013H. TF1 that is timer 1 vector address is 001BH. And all these interrupts, the flag clearing is automatic. And for serial port interrupt, that is RI and TI, vector address is 0023H and the flag must be cleared by the programmer. And to enable or disable all these interrupts, there is a register called interrupt enable register. And to change the priorities of these interrupts, interrupt priority register is used. Let's see these registers in detail. So IE is nothing but a interrupt enable register. This is an 8-bit register. So first bit or 7th bit of this register is EA, that is enable all, or this is also called as a global enable input. If this bit is 0, all interrupts are disabled, and if this bit is 1, all interrupts are enabled individually. Bit 6 is reserved for future use. Bit D5 or 5th bit is nothing but the enable disable bit for timer to interrupt. Then Fourth bit is used to enable or disable the serial port interrupt. D3 bit is used to enable or disable timer 1 interrupt. EX1, that is bit D2, is used to enable or disable external interrupt. ET0 is the enable disable bit for timer 0 interrupt. And EX0 is used to enable or disable external interrupt 0. IP register is nothing but the interrupt priority register. This register is used to change the priorities assigned to the interrupts. So this is also an 8-bit register. Bit D7 and D6 of this register, they are reserved. Then bit D5 is used for T2, that is timer to interrupt priority bit. Then bit 4 is used for serial port interrupt to assign the priority. Bit D3 is used to assign the priority for timer 1 interrupt. D2 is used to assign priority for external interrupt 1. PT2, that is bit 1, is used for timer 0 interrupt. And D0, that is PX0, this bit is used to assign priority for external interrupt 0. So let's see how we can assign the priorities to these interrupts. If here we put IP equal to 00H, that means we are not assigning any bit equal to 1. All the bits of this register, they are 0. So the default priority is here, that is E0 has the highest priority and RITI has the lowest priority. If we want to change the priority, suppose here we are making this bit D3 equal to 1, that means we are assigning the value 08H to IP register. So we get here the priority, that is T1, we are assigning the priority to timer 1 as a highest priority. So we get TF1 as the highest priority, then int0, TF0, int1 and RITI. If we place IP equal to 12H. So here we are assigning priorities to the serial port and timer 0. So we get here as in default priorities, TF0 has the highest priority than serial port interrupt. That's why here also the TF0 has the highest priority than serial port interrupt. So TF0 at highest priority, then RITI has the lowest priority than TF0, and all the rest of the interrupts they are has the priorities like this. So TF1 has the lowest priority. So in this way we can change the priorities of the interrupt registers. So here are the questions based on this video. What is meant by the term ISR? How many serial interrupt has the 805 in? How many hardware interrupts has the 805 in? How are they activated? Which bit of IE register belong to the serial interrupt? Which is the highest priority interrupt of 805 in? Draw the format of IE register and explain the function of each bit. Draw the format of IP register of 805 in microcontroller and explain the function of each bit. Assume that IP register has all zeros. Explain what happens if both TF0 and TF1 are activated. What address in the interrupt vector table is assigned to timer 1? Thank you.